to discard your mental blinders. CounterThink with Mike Adams is now live on Infowars.com.
Well, we've got a really special show for you today. Thanks for joining me. This is Mike Adams here. CounterThink is the name of the show at Infowars.com. It's broadcast every Sunday at 6 p.m. Central Time. You can also catch previous episodes at CounterThink.com. So today, I mean, look, you know we challenge the establishment thinking on everything. And today is the biggest topic that we've ever tackled. It's the topic of the nature of reality, the nature of the cosmos, the beginning and the existence of everything, all matter, all energy, even, consciousness and human existence. Where did it all come from? Now, of course, many people who are atheists out there and don't believe in a divine creator say there was a big bang, that the entire universe that we see today, they say, came from nothing, and that, in other words, everything came from nothing, and it happened without cause, which seems kind of insane, right? If you think about it logically, how could everything be caused by nothing without any reason? But that's the official view of mainstream science, and literally that's the official view. And then there are those who are more the creationists who say, well, no, there was a designer, that God created our world or God created our universe. And then some people say, well, maybe God created the Big Bang. So maybe there's more than one Big Bang. Some say there's a multiverse of different universes out there. And maybe God, or some say even an advanced alien civilization, they say, is running around like dropping seeds of Big Bangs all over how do you even say it, the fabric of reality, creating universes here and there and everywhere. And then there are some scientists who say, well, all these different universes have different constants, have different strengths of the weak nuclear force or the strong nuclear force or electromagnetism or gravity constants, and that there are different universes that have different constants, and some universes just implode and cease to exist. And then other universes are perfect for developing planets and life, and that's the universe in which we find ourselves. I mean, the explanations run the gamut. And what you choose to believe says a lot about, maybe your faith in life, your faith in the universe, your faith in God or not, perhaps your belief that there is no God. But we're going to ask some big questions on this. Today we're going to be joined by a guest named Joseph Glenn Jessome. He goes by Glenn, and he claims that there is no Big Bang, that there was no Big Bang, that in fact, in essence, the things that we've been taught about the origins of the universe are flawed or even just flat out false. He's not claiming that it's an intentional fraud, but that the mainstream scientists are wrong, which of course they've been wrong, throughout history. Science is always being corrected. There's always new revolutions in thinking and understanding. And many of those revolutions have been started by, independent thinkers who dared to challenge the status quo. Albert Einstein himself, for example, challenged the status quo. Einstein, his theory of general relativity was considered, total bunk at first by mainstream scientists. They say, well, what do you mean everything's relative? What do you mean that time and space can be twisted around like that? Even notions like gravity can bend light because gravity warps the very structure of the universe itself. Orbiting planets are actually traveling on a, quote, straight line because gravity itself twists and distorts the universe so that an orbit is actually a straight line according to the conservation of motion by the planet itself. These kinds of concepts, which are now accepted as mainstream science, were once thought to be totally insane. I mean, there was a time when people thought that stars couldn't possibly be other suns because they're so much dimmer that they would have to be, billions and trillions of miles away to be stars, and no one thought that the universe was that big. Well, it turns out it is that big, and it's way bigger than probably most of us can imagine. So there are big questions, there are big events happening, and we're seeking answers. That's all. That's what this is all about. So I'm going to be joined by Glenn Jessome, who will help us explore this very tricky subject matter. Not claiming we're going to find all the answers here, of course, but we're going to ask some big questions. That's what this is all about at CounterThink. So stay with us. We'll be right back.
Doing what you're told without knowing why is what they want. CounterThink with Mike Adams.
And we're back on CounterThink. Thank you for joining us. We're tackling the big issues today, very big questions about our universe, the nature of time and space itself. This is, you know, these are the biggest questions that we've ever asked yet on this show. You can't get much bigger than the cosmic questions that we are asking today with our guest who now joins us. His name is Jessome, and he says that the Big Bang didn't happen and that time is not the fourth dimension, and he's got some very interesting views to share with us on these subjects. He joins us by Skype video today. Glenn, as you'd like to be called. Glenn, welcome to the show.
Thanks for having me, Mike. I really appreciate it. It's long overdue.
Oh, it's great to have you on. Now, is Glenn your middle name then, or is that how?
Yeah, it's Joseph Glenn Jessome, and I go by Glenn. It's a family tradition. There's a lot of us middle name guys.
Oh, okay, great. All right, so let's start with the basics. I mean, the big aha, when people hear something like, oh, the Big Bang never happened, they immediately say, well, wait a minute, that contradicts, you know, so-called accepted science. How, on what basis could you assert that the Big Bang never happened? Start wherever you want on this, because we've got some time for this whole show, but that's the big question that's in the mind of many people. So go ahead.
Okay, when tackling questions like this or any questions, I engage in what's called first principles thinking, trying to get to the basic truths and build up. And Alex Jones has a great line. I always love when he says it. He says, don't believe me, do your own research and draw your own conclusions. So what happened with me was I had misgivings. I was a math, physics, calculus teacher, and I had misgivings about a lot of theories, but I didn't have the time nor the inclination to really delve into them. And when I was 7 years old, I picked up my dad's encyclopedia, and it said the matter in a black hole was so dense that you could fit 50,000 tons in a matchbox. Now, recently, I tried to go back and see where I could find that. And as far back as I could get was 84, and at that point, they were talking about billions of tons in a matchbox, which I think is science fiction, not science fact.
Well, but they're just saying it's very, very dense material, you know, collapsed atoms, perhaps, just super dense.
Yeah,
right?
Super dense material is what they're talking about. Yeah, but I thought it was inconceivable then, and I still think it's inconceivable now. And so that was the impetus for it. But so where can we start? Let's start at the beginning of the Big Bang Theory itself. The Big Bang Theory was first called the primeval, I can pronounce it a couple ways, but primeval atom theory. And that theory was proposed by a physics professor who happened to be a Jesuit-educated Catholic priest. And so this priest's name was George Lemaitre, and he proposed the theory in 1927 based on some observations by Edwin Hubble and based on a theory of general relativity. And so the interesting thing was that I've said to people, and this gets people a little upset sometimes, but
hey, that's okay. This is called CounterThink. You're allowed to upset people. Go for it.
Yeah. Well, the Big Bang is a Catholic creation myth because it came from the Catholic Church. It got the blessing of the Catholic Church, and somebody could make the statement. They could say that you know, he was a low-level priest. People don't realize the Vatican has a Pontifical Academy of Scientists, and the Vatican's Pontifical Academy of Scientists, the president from 1960 to 1966, when he passed away, was George Lemaitre, the gentleman that coined the Big Bang Theory. So the Catholic Church was very much behind the Big Bang Theory.
Well, wait a second, because I think most people in their memory, they would say that the Catholic Church was opposed to this idea of a Big Bang, that the Catholic Church had always been just creation, that creation, you know, God created the universe. But then sometime more recently, I don't remember what year it was, didn't the Catholic Church say that the Big Bang was consistent with the idea of a creator? Is that correct?
Yeah, it was in 2014, the Pope came out, and a lot of people, a lot of Catholics who had, the reason that perception was there, it's a natural perception because atheists like Stephen Hawking and a lot of other famous atheists, they pushed the Big Bang Theory. So people were under the impression that it was an atheistic theory.
I see.
But if you actually know the history of the Vatican's Pontifical Academy of Scientists and the who's who and who networks with who, you'll find a lot of big names in the Vatican's Pontifical Academy of Scientists, Schrodinger and... Yeah.
Well, I'm sorry to interrupt, but so this means you're saying that there was no Big Bang. You have an alternate explanation for it. So you're saying that the Vatican was wrong, that this was a Vatican myth. I think is the phrase that you use. But also,
I call it a Catholic creation myth. Yeah.
Is that correct?
Yeah, I call it a Catholic creation myth.
I'm sorry, a Catholic creation myth. But
yeah.
also, you're saying that the atheist scientists who oppose the church, who are saying that the Big Bang is how the entire cosmos began, you're saying that they're wrong too, correct?
Yeah, I'm saying both are wrong, and like, you know, there's science and then there's scientism. Is when people have a belief that, you know, people often say to me, well, science says this. And I say, what's science's last name? Is he related to Simon? Because Simon says things too. To me, if it agrees with first principle thinking, critical thinking, and logic, then it can be proven. If not, it's just a popular theory. So to further, go ahead.
Yeah. Back us up then. I'm sorry to interrupt with all these questions. Of course, it's a fascinating subject for so many people. But so where is the Catholic Church wrong, and where are these scientists wrong? If there wasn't a Big Bang, then where did everything come from, or did it always exist, or what's your take on that?
That's a fantastic question, and I can't give you context for it right now because we'd be getting ahead. I just want to further one tiny thing. Can you see this book here?
Yeah, Brief History of Time, Stephen Hawking.
Yeah, this book here sold about 10 million copies, I believe. And interestingly, Stephen Hawking was invited by the Pope into the Vatican's Pontifical Academy of Scientists in 1986. And 2 years later, he had enough marketing money, and the Catholic Church's universities were behind it, to sell 10 million copies of a book back in 1988. That's a lot of books.
Wow. Yeah.
So when I say it, it's not just an opinion. There's way too much evidence that I can tell you that it's a Catholic creation myth. Now, how do we debunk it? Fantastic question. We have to delve into space and time. And ironically, Stephen Hawking's book, A Brief History of Time, nowhere in the text does it say what time is and what time isn't.
Interesting, because I have read that book, A Brief History of Time, and I believe it goes into some cosmology, a little bit of astrophysics, the motion of the planets, relativity, issues like that. But you're right, I don't recall him actually defining time.
No, and there's a slide that just got pulled up there that speaks. It's a great slide. It's a great quote. Sort of it seemed like I pat myself on the back there, but no, there's a great quote there by St. Augustine, and he basically said, "What then is time? If no one asks me, I know what it is. If I wish to explain it to them, I do not know." And so that was a quote that goes back to around the 300s AD. And interestingly, just so you know that it's not just my belief, this is a cover of a magazine article.
Yes.
And this cover, this magazine article, it came out twice actually when I looked it up. First time I bought it in 2012, but I think they did a reproduction of it as well. And it says, "A matter of time. It begins, it ends. It's real, it's an illusion, it's the ultimate paradox." Einstein had given up on the notion of ever understanding time. He was really going after gravity, but gravity is a product of time. And so if you don't understand time, you're not going to understand gravity.
All right, so we've got about a minute left here. That's our time for this segment, just to throw that at you. But so how do we get a grip on understanding what time is? You say certainly time is not the fourth dimension. That makes a lot of sense. Time doesn't seem like a spatial dimension. So what is it?
Time is, I like to talk about two types of time. In Einstein's famous papers, he defined times as that which clocks measure. Now in logic, you can set up defining something as something and then draw conclusions there from it. But the natural phenomenon of time is not the same as clock time. And I'm going to help your viewers discern between the natural phenomenon of time and clock time. And they are two different things. But before we go to break, I'd just like to say this. You hear the concept space-time all the time. And when I hear it, it's like nails on a chalkboard for me. Right?
Because you're saying natural time is different from space-time.
Well, yeah, well, not only that. What I'm saying is they have the order reversed. When they say space-time, right, they actually have that order there for a reason. They believe it's space first and time second. Space was more fundamental.
Okay, we're going to go to break. We're going to go to break, Glenn. We'll be right back here on CounterThink with this fascinating topic of the nature of time. We'll be right back in due time. Stay with us.
Countering the brain-dead propaganda of the status quo. This is CounterThink with Mike Adams, right here on InfoWars.
And we're back on CounterThink, tackling one of the more interesting subjects that we've ever covered, which is the nature of the universe itself, time and space. And our guest today is Joseph Glenn Jessome, who has some rather fascinating theories that question the status quo on the nature of time and space, and Stephen Hawking and Albert Einstein and all of that. So Glenn continues to join us by Skype for this segment and the next one as well. So Glenn, before we went to break, you were talking about the nature of perhaps space being an emergent property of time rather than time being a property of space, as the establishment claims. Is that correct?
That's exactly, and I think that logic will back me up on that. We'll see in a few moments. There's an old saying about a lie told loud enough, long enough, often enough will be believed by the people. So when people keep hearing authorities say space-time, they think that's the order. When they hear Big Bang and big names attached to it, they put more stock and they put more belief in it. And so people will ask, who am I to question that? I'm not an anarchist. I'm not questioning it for the sake of questioning it. I'm saying, look, I don't even like the word theory as it applies to my work. My work is not theoretical, it's modeling. And so if you look at my model, you can look at my model, look at the current model, and you can see which one seems more logical to you.
So we're going to put some of your documents, I think some slides from you, by the way, on CounterThink.com. So for those of you watching this, if you want to download some of the slides that Glenn's referring to, you can just find those at CounterThink.com. But take us back to the whole structure of time itself. So is there a way that the human mind can grasp what is time if it's not just some emergent property of space? What is it really?
Time, for me, I say time is the cause of all physical change. So what we're going to do now is we're going to go have a look at the current model and how it's constructed, and mine, and we can compare the two, and your viewers can make their decision if anything I say has merit. Okay,
so which slide should we bring up for that?
Okay, we're going to bring up slide 10.
All right. And what is this showing us? Go ahead and describe it, Glenn.
So slide 10, I have a title on there. We don't have to go through that, but basically, even people, like a lot of people turn off when they hear the word math, and Stephen Hawking's editor told him for every equation he put in his book, he'd lose half his readership. So he put in 1 equals MC squared. So basically, everybody understands what a point is. We understand what a line is. We understand what a plane is. And we understand what 3D space. Those are basic concepts that we learn in elementary math, and they're used quite a bit. But what I've done is just looked at it just a touch deeper, and I said, and it's so simple. But I say an infinite amount of points make a line, an infinite amount of lines make a plane, an infinite amount of planes make 3D space. You're visually getting bigger as you do that. And so if you go to the next slide, slide 11, not only do points make lines, you can see the first arrow there, points make lines, and points make planes, and points make 3D space. Lines make planes, lines make 3D space. So I call that the mesh direction, and it's important that we get our head around that mesh direction because it's giving us some order in a little bit simple, but a little bit more deeper and fundamental look at the constructs that we know of.
Well, if I could summarize this, so you're saying 3D space contains planes, lines, and points, but if you step down a level to, let's say, lines being just really 1D, I suppose, they don't contain planes because a plane is a 2D definition, correct? Is that what you're saying?
Exactly. It's more complex. You get more complex and larger as you go up there. And there's lots of different ways you can put words around it. And that's one of the big problems with time. There's so many metaphors, and we'll get to that later too. So there's a slide 12 there that for people that are interested in math and geometry can have a look at, where I show some patterns with respect to how many spaces there are at your different levels. Now 13 is where I break up, and that's worth reading.
Well, this seems like geometry. How does this? Because the time of the show here is limited, so you're going to have to map this to the structure of time pretty quickly here. How does?
Okay. So what I'm saying is the natural phenomenon of time. Once we look at the natural phenomenon of time, which I say is the cause of change, all right, I'm going up to slide 17, and I'm saying what they did. Slide 17, they said you got points, lines, planes, 3D space, time. Now, not to take up too much time, but it was Einstein's teacher, Hermann Minkowski, who called Einstein a lazy dog. He was impressed with Einstein's work in 1905, and he put time in the fourth dimension in a paper in 1908 that contained Einstein's special relativity, and he convinced Einstein to use his model, where they would treat time as the fourth dimension.
And when you say the fourth dimension, you mean a fourth spatial dimension?
Well, they put it in the fourth place, and again, it depends on who you're talking to. Some people will say it's literally the fourth dimension. Some will say it's metaphorically. There's all kinds of wordplay, and when you try to nail anybody down, they can't really give a justification. There's no logical justification for putting time in the fourth spot. Whether you're saying it's literal or metaphorical, because you're visually getting bigger, what does time look like? Well, time doesn't have a spatial construct.
So if this is, you're saying this is the traditional model that's out there right now in mainstream physics, correct?
That's the traditional model out there in mainstream physics. That's where they put it. Some people think it belongs there. Some people just put it there because they don't know where else to put it. And I'm proposing a new solution now that's not merely a trifle position. So if we go to the next slide.
Yeah, show us where they're wrong and show us what your concept looks like.
Okay, so a point is a point holds a position. A line, we know what a line is between 2 points. We know what planes are. We know what 3D space are. You're visually getting bigger. And what I like to tell people too, that we have to be careful, because when we're teaching these things in math, if you put a point on a chalkboard, there's actually a thickness to the chalk, right? In reality, it's a representation of a point.
Sure,
a line,
it's a metaphor.
There's no such thing as a line, exactly. And that's why string theory just drives me foolish, because they talk about one-dimensional strings. Well, there's no one-dimensional reality that we can experience.
Yeah.
Okay. Same thing with a plane. We say we're going to a 2D movie or a 3D movie. Well, we know what we mean. There's going to be some more depth perception with a 3D movie versus a 2D movie, but still a 2D movie. The screen has thickness. The light waves have thickness. So what I said was, if time is not spatial, and I said points have no units that we measure with. I use metric, you guys use feet, but I use meter here in Canada. And I say lines are measured in meters, planes are measured in cubic meters, or planes are measured in square meters, volume is cubic meter. If you're following that pattern, time would be meters to the fourth.
Yes.
Does that make sense to anyone?
Well,
and
I mean, a fourth spatial dimension would be meters to the fourth power, right?
Yeah. So what I'm saying is, let's try, I call it Jessome time, because I came up with it. Let's try the natural phenomenon of time, subspatial. So I'll call it the -1 dimension. And interestingly, when we put it back there, some relationships emerge. And we can say, okay, so if change is not a thing, change is not a spatial construct, okay?
We've got 20 seconds in this segment, by the way.
From nothing to something is a point. From nothing to something is a line. From nothing to something, right? Here, Indian yogi will even tell you, time is nothing, right? It's change.
All right, so
right?
you're saying
not a thing.
You're going to call time the -1 dimension, which probably doesn't make any sense to our viewers yet. So you're going to have to wrap this up. When we come back, we'll be back after this break here on CounterThink with Glenn, Joseph Jessome here about the nature of time. Stay with us.
Exposing the corporate media assault on your reality. It's CounterThink with Mike Adams.
There are no doubt going to be a lot of mathematicians and physicists and cosmologists, astrophysicists watching this episode of CounterThink and saying, well, you're trying to blow apart, what is it, maybe 80 years or 100 years of the system that people have come to know and trust, that's put out there by scientists, maybe the standard model of atomic physics, all these things, the nature of gravity, the nature of time and space itself. Are you trying to, and joining us is Glenn Jessome here. Glenn, are you are you trying to say that Einstein is all wrong? And I mean, I know that's not what you're trying to say, but.
Okay, well, I'll say what I'm trying to say. Yeah. Einstein himself, in this book, this is the seminal work of a biography on Einstein. I read it, and I haven't read many books because I'm a slow and methodical reader. I'm not fast at reading. Einstein said for the last 30 years of his life, there's flaw in general relativity, and I can't find it. He even went so far as to say, since the mathematicians got a hold of general relativity, I hardly understand it myself. People thought he was joking and being coy. He wasn't. He's being dead serious.
Well, there's one thing that I have noticed, and when I read physics books or astronomy books, I notice that they're always using constants, and these are fudged numbers. There's about, I don't know, 15 or 20 constants that they use. Like there's a constant for gravity, there's a constant for, you know, the strong nuclear force, for example. And these are like fudge numbers, and no theory out there can explain where these constants come from. They have to just kind of derive them experimentally and plug them into their equations, and they shift them around from time to time, right?
I'll send an email to Rupert Sheldrake and get him to come on your show. He'll explain it much better than I will. But back to this, Rupert Sheldrake, he's an expert on that. He does a great breakdown on it, and I'll see if I can get him on your show.
Yeah, I'd love to. I've read his books too. I mean, yeah, he brings up a lot of important points. But I was just trying to confirm what you were saying, that there's a lot of fudge factors. So seems to be you're saying that even Einstein admitted that there were some gaps.
Oh, yeah, there are fudge factors in science. We know this. But what I'm saying here is that this is an error and a mistake. I'm not saying they did this intentionally whatsoever. What I'm saying is there was a mistake. Minkowski convinced Einstein, and it took him a while to put time in the fourth dimension. So if we look at slide 21, you will see where I put Minkowski space-time next to Jessome time-space, where the order is reversed. That's the... Oh, that didn't come out right on your end.
Well, that's okay. We can kind of read behind the arcs there. It's okay.
Okay, yeah. Hopefully we can put up a better one for production. So what I'm saying here is that the current model is not logical, and my model is logical. What I'm saying, change, the cause of change, which is not visualizable, but 3D space volume is changed from nothing to something. Okay, so my view of it is continuous and logical, and their particular view is not continuous, not logical, and it's not just a minor difference to think of time then space. And we'll see that as we go now, because right now we have to skip a lot of my work.
No, but you're saying that time is a substructure or a sub. What would be the best way? Like a fabric of the cosmos, even underneath one dimension.
It's interesting you say that, because you're still treating it like an object and a medium.
I know. Well, we have to use words.
It's in our language. It's in our language.
Yes, it is.
The metaphors are always, or nearly always, we say timeline. I'm going tomorrow to an event. There's a timeline. Oh, time is linear, past, present, future. Now, those are three concepts that we put past, present, future. We put them in that order. But time, the natural phenomenon of time, is the cause of motion. It's the cause of gravity. It's the cause of consciousness.
Whoa. Wait a second. Well, can time flow backwards? Because I believe there's some theoretical physicists who say there could be time symmetry, and
again, just think of what you said. Time flow, right?
Yeah, but can it be reversed? Can cause and effect reverse?
No, not with time. It never has and never will be. Time is the cause of flow. Flow's not. If I say to you, your father's the cause of you, you're the cause of your children. Could your children be the cause of you and your father? That's not how nature works.
Sure. No, I'm just talking about theoretical physics. Sometimes they talk about maybe it's just mental models.
They worship equations, and their equations work good and forward and reverse. So they say, oh, well, there's no real reason. Well, I don't worship equations.
Okay.
I use them.
Fair enough.
But I don't worship them. So where does this? Somebody asked me today, well, how is this relevant? Well, how it's relevant is our current model of the universe, of everything that we live in here, the physical universe. The current model is a Big Bang theory, and they have something called the Planck epoch, and the foremost theory prior to the Planck epoch, which is milliseconds after the Big Bang event. So it goes like this: the mainstream narrative with Hawking and Hertog and Hartle and Davies, they all say that once upon a time there was no time, there was only space. There was three dimensions that spawned out of nothing for no reason, for no purpose. And there was a fourth dimension of space. Now, there was a great expansion without time. Where have we ever experienced expansion without the natural phenomenon of time? If time's not progressing, what's changing?
Yeah, this is called inflation in the Big Bang Theory.
Inflation, yeah, but they're saying it inflated. So at slide 36, these slides are actually pulled from a documentary that was done last fall with Stephen Hawking, James Hurtle, and I think his name is James Hertog. These three individuals were explaining what the origins of the universe were, and they say, you can see the slide there on
Yes.
36. It says that you had, now what they're doing there is they have 3D space, they're representing it as a disk, okay? So rather than visualize 3D space, whether they flatten it out to a disk so that they can show it progressing. And so you have a 2D disk, which represents 3 dimensions, and it's getting pushed along and expanding, and expands greatly. They call this the shuttlecock, the no boundary state proposal. The language gets complicated because it's wrong.
So they're saying that the very fabric of space and time did not exist before the Big Bang, that the Big Bang brought into existence space and time, but it all happened without any cause whatsoever.
And what they're saying, exactly.
I do find that suspicious. How can something happen without cause?
You have a non-causal universe model. That's the Big Bang.
So in other words, the Big Bang Theory sounds like science magic. It's just
friends of mine call it math magic. Yes,
math magic. Okay.
Yeah.
Right.
Actually,
so
there was a guy. He was a hippie, and he did a lot of entheogens and drugs. I'm blanking on his name. It'll come to me in a minute. But there's a gentleman. He said, the Big Bang Theory. I know it well. It's give us one free miracle, and we'll sort out the rest. Where all of the all of the laws of physics break down, and many of the rules of mathematics have to get thrown out.
Well, that's a great way to say it, yeah. So even the people who are promoting this theory say there has to be one great miracle, which is the creation of everything out of nothing. Yes. And then from there, they say there is no God, nothing divine happens, everything's cause and effect. Is that about right?
Exactly. And I say, there's an old book that says judge a tree by its fruits. And when I look at the periodic table, I see design. And whenever I see design, I think designer. And when I look at DNA, if you ask any, top-notch biologist in the world, you say, what is DNA? They say, it's code. Where in the universe is there code that there wasn't a coder? So we've got coding and designing going on here. But the mainstream science version is given enough time, anything will happen.
Yeah, that is interesting that DNA is, it's binary, it's digital. It's actual digital code encoded in every cell of your body, which is kind of a holographic storage mechanism if you think about the fact that it's stored in every cell throughout your body, and that there are certain cells that can create another version of you through, technologies. That is fascinating.
Yeah, so we have a non-causal model. That's a great way to explain it, a non-causal model.
Well, you certainly have us thinking. We're going to keep you for one more segment here, Glenn, because you've got a lot of interesting things to say. People are going to be bashing their heads against the wall trying to figure out some of the doors that you've opened here, hopefully in a positive way. Maybe they shouldn't be practicing the Big Bang with their foreheads, but we'll be back to check all that out. Stay with us here at CounterThink. We'll be right back.
Prepare to discard your mental blinders. CounterThink with Mike Adams is now live on Infowars.com.
I was thinking during the break, I'm surprised that the same people pushing climate change taxes haven't come up with the Big Bang tax. Because then they could say that if you don't pay Al Gore, the entire universe is going to collapse because it's a Big Bang tax. You're contributing to the Big Bang by having mass, and thus your very existence is causing, the contraction of the universe. I mean, who knows? What the things that politicians do in the name of science drive all of us crazy and make us all want to participate in some kind of big banging of our heads against desks or something like that. But Glenn Jessome joins us back. All humor aside, Glenn is a serious guy who's got seriously questioning the accepted, sort of mainstream theories on gravity, relativity, the nature of time, the cosmos, all those big questions. Now, of course, we can't really do it all justice right here in this short, conversation. So go to counterthink.com. There's a slideshow from Glenn that you can download there, and you can read some of his more detailed slides, and you can begin to pursue this with your own questions. So Glenn, welcome back. Let me ask
Hi,
you
Mike.
this question. According to mainstream cosmology, they believe there was a Big Bang because according to, for example, redshift measurements of galaxies and stars, they say that everything is moving away from us, so that the entire universe is expanding dramatically. And then, of course, they fabricate all this dark energy and dark matter to try to fudge a bunch of things that they can't detect and they can't prove. So whatever, it sounds like a bunch of, you know, hoax, science, dark matter, fudging factor to me. But what's your take on all that?
Okay, my take on, well, it's going to eat up too much time, but just quickly, you and I are on the same wavelength, because I was just going to backtrack and explain. Before we went to break, I was explaining what the Big Bang theory is, the initial conditions. Okay, but in my haste and rushing, I forgot to explain why they come up with it. And you're exactly right. It was Edwin Hubble was the first to look out and see redshift at the farthest celestial bodies, and he said that they're moving away from each other. So he logically deduced, because they're moving away from everything's moving away now, they must have been doing that. And that's when Georges Lemaitre came up and said, well, if they're moving away, if we reverse time, they must have been all together. And that's not the case. You and I could both start moving away from each other right now, but I mean, I'm in Canada, you're in Texas.
Yeah, but I think they're saying that these galaxies have had consistency of motion. What would cause them to suddenly accelerate away?
Here's an interesting thing, and again, I don't have time to explain all this work, nor have I read all of it, but there's a guy that your viewers should look up. His name's Halton Arp, and he found anomalies with redshift, and he wrote 2 books. One's called Seeing Red, and the other one's called something about Peculiar Galaxies. I highly recommend people, before they believe in redshift, have a look at one of the best astrophysicists ever to come out of the United States, and he actually had to leave. He was forced to leave. They literally took away Halton's Arp telescope time for questioning the mainstream narrative. And he passed away. He lived his life and worked in Germany, I believe at the Max Planck Institute or something. But they wouldn't let him on the big telescopes because he wouldn't agree with their beliefs. He saw data, and he wanted to say, hey, if the data doesn't fit, we have to relook at our model. And they wouldn't look at the model. They'd rather change him.
Well, right. I've got questions about redshift as well. I mean, one obvious question is that every time that the science books talk about the Doppler effect in the cosmos, they always use this example of the Doppler effect of somebody standing on a street corner and a police car drives by, and there's this siren sound and the frequency changes as it's approaching you, and then the frequency lowers as it's moving away from you. And then they say that the same thing happens in outer space. And I'm thinking, well, wait a minute. The Doppler effect obviously works in atmosphere because sound has a limit of speed in the air, but space is supposed to be empty. Is there a speed limit that, you know, that is some structure of the universe in some way? How can there be a Doppler effect in electromagnetic waves?
Yeah, the best thinkers I've talked about have the same issue with it. We talk about it having I use the word terminal velocity. Sound has a terminal velocity in a medium. Light has a terminal velocity in a medium. You can't add to a terminal velocity. But before we lose too much time on redshift, which is probably a little more complex than most people are into, I'd like to go back. I'd like to go back and give a gift to the people.
Okay, hold on, Glenn. But I got to ask you this thing. Yeah. So they're saying that planets are, let's say that they're saying if a planet, or I'm sorry, a star or a galaxy is moving toward us, that would be a blue shift. And what they're saying is that the speed of light emanating from that galaxy is exceeding the speed of light because it's the speed of light plus the speed of the galaxy's movement relative to us. So they're saying that light can exceed the speed of light.
No, that's not what they're saying there, Mike. They're actually saying that the waves get compressed. When you have something, you can't add to the terminal velocity. So they're saying that, like the Doppler effect, they're saying that the light waves get compressed and then they'll go to the blue end of the spectrum.
No, I understand. Actually, what I mean is they're saying one or the other. They're either saying that the light waves get compressed because there's a medium of transmission that limits the speed of it, or they're saying that light can travel faster than the speed of light and that it's arriving at Earth. We're perceiving it with a higher frequency because it's arriving faster than the speed of light. One or the other has to be true, it seems. I should have clarified my statement. I'm not saying that they're claiming my description.
Well, special relativity also has flaws in it. Yeah. But again, all I want to do is knock down the Big Bang today if I can.
Okay. I'm sorry.
Not being rude. I just don't want to get the hook at the end and be left there not with getting it out. So
all right, the floor is yours. Go ahead. Sorry.
Okay. So redshift is what led Georges Lemaitre to come up with the primeval atom theory, which got its name from a disparagement. Sir Fred Hoyle, who thought the theory was bunk and knew it was bunk, was disparaging it on BBC. He called it the Big Bang Theory, and the name stuck. So it's not a compliment. It was a disparagement. Now, so what I'm saying is I am not a big banger. I don't think there's any evidence that even if the farthest bodies are moving away, doesn't mean space is moving away. And that's what they've said. They said that the whole universe, the Big Bang, could fit on the top of your finger and then absolutely nothing, a singularity. It's nonsense. However, I will throw the dogs a bone and say this. If you're going to have a Big Bang, slide 37, please, wouldn't it make more sense that instead of having one dimension of space that was time-like, wouldn't it make more sense to have time change and 3D space? Now, again, I have to qualify it. I'm not a Big Bang, but I'm just saying you could correct the Hartle-Hawking state. If there's a massive expansion, right, then there has to be time, the cause of change. There has to be, if something's changing, without the passage of time, nothing physical changes, right? And even that's not the proper wordage, but I'm trying to use words that viewers understand.
Right.
Time is not a medium. Time is not an object, okay?
Right.
It's more in line with the concept and the construct. I say to you, Mike, do you love somebody? And you say, yes. I say, is that love real? You say, yes. I say, okay, how much does that weigh, that love, if you put it on a scale? How much volume does it occupy? What's the gravitational pull? It's real, but it's a real concept. It's not a construct. And we keep treating time like a medium, an object, or a construct.
I see.
And what I'm saying is, if you look at my correction, now again, if somebody that's a Big Bang wants to say, hey, the no boundary state, why do we have to do that? Why wouldn't we just say if things were expanding, there was time, and then there was, and then there was space secondary? That makes more sense, because I think that's how the universe perpetuates.
So, but the implications, we've only got about 2 minutes left here. The implications of what you're saying really means that scientists have to take a whole new look at the origins of the universe. And doesn't that mean then that you're saying that the universe, that the physical space has always existed?
It could have. I love to say I don't know sometimes, and I think a lot of scientists should say it more when you don't know. But I can say this, just because the farthest objects in the universe are moving away, they're moving into a space if they're moving away. So the space is there.
Well, right, of course. But
they're treating space like an object. Right. They're treating space like a medium. Now, we do know that we have electromagnetic fields. They're now saying that there's a Higgs field. There's various different fields in space. We're right back at the ether. But continuing on with the Big Bang, what I say is this, is that if you had time, and then you have time pushing along 3D space like we have, or the contents of 3D space would be more like it, but there's no need for a Planck epoch. And interesting, a colleague of mine, and I would love people to look him up and check out his YouTube channel, Sky Scholar. His name is Dr. Pierre-Marie Robitaille. He works at Ohio State University. He is a professor. He once held the Guinness World Book of Records for the highest resolution MRI image ever taken. And he says that this birthday picture, you could bring it up, the cosmic microwave background. They always say it's a birthday picture of the Big Bang. He says that the data was fudged when they put it together. And even if they didn't fudge the data, the satellite that collected the data wasn't far enough away from the Earth's oceans. For saying that, he's deemed a heretic of science. And
Glenn, speaking of time, we are out of time. I understand this is just the beginning of this conversation. Folks, check out the slideshow from Glenn at counterthink.com. Wow. I mean, okay, so a lot of questions. A lot of people are going to be opening doors and opening books and thinking about where this leads, but that's what the show is all about, asking the big questions. Thanks for joining us. CounterThink is the show. Take care.